Good afternoon. My name is Steve Constable, and I'm the current president of the Institute of Agricultural Engineering. And I'd like to thank you all for joining our September lunchtime lecture today. I would like to welcome Benjamin Turner from Agrimetrics, who's an IAgrE member and a chartered engineer, and is going to talk about the fascinating subject of big data. After Benjamin graduated from Imperial College London with an MEng with honours, he progressed through various senior management roles before his current role as Chief Operating Officer for Agrometrics. As normal, before we start, you should all be on mute. If you'd like to ask a question, then please use the chat function. And at the end of Benjamin's presentation, you can unmute and ask individually, or Benjamin will ask you, will unmute you and ask you to ask your question. So without further ado, I will hand over to Benjamin.
That's very kind. Thank you very, very much, Steve. Hello, everybody. I do know a few of you as well, which I'm very pleased about, because obviously I've only been in this industry for 5 years myself, since I joined Agrometrics. So it's great to actually see a few familiar names on the screen. So yeah, so I've been in this industry for 5 years since I joined Agrometrics, and come from a data and analytics background across a number of different industries: retail, hospitality, financial services, professional services, and building management systems. I'm a chemical engineer by training, so understand those kinds of process systems and control, etc. And got my chartered engineer certification about a decade ago, based on my career in computing and technology. Another credits to my name is that I've been a member of the Livestock Information Services Data Advisory Panel over the last year and a half or so. So a quick introduction to Agrimetrics. Most of you may know that we're one of the Innovate UK funded agri-tech centres for agricultural innovation. We're a data exchange and a data marketplace, delivering a part of the essential national data sharing infrastructure for the UK, increasingly looking internationally. So there are a number of organizations that we're talking with around the world around how we can become that data exchange powering their agri-food sectors as well. So that's part of our mission statement now, is to become that data exchange powering the world's agri-food sector, not directly, behind the scenes, allowing others to be able to be front of house, as it were. We work with businesses, research organizations, governments, to help them to offer, find and use their data to create valuable analytics and insights so that everyone can collaborate around data. So you've got the UN Food and Agriculture Organization saying feeding 10 billion people by 2050. It seems a long way away. It's hard to imagine what UK farming might look like then. It is tempting to think it'll be just broadly like what it is now, but with a few incremental improvements. But actually that kind of picture doesn't really recognise how far we've come just in the last 30 years, with the accelerating pace of change driven by technology, data, analytics, and also the need for systems level fundamental change to meet these grand challenges ahead. I know you're all really, really well versed in all of these challenges. It's something that I'm sure we all talk about a lot. Moving on to 30 years ago, this picture was labelled Tractor Legends from 1990 on Farmers Guardian website. No ubiquitous internet, few home computers, no mobile phones, let alone smartphones, no GPS. A genome sequence was a dream, and everything was done on paper. Farming decisions were pretty much all guesswork. And now, over the last 30 years, this wave of consumerism, of choice, of globalization, environmentalism, and the increasing uncertainty and risk around population growth, climate change, market volatility, input price rises driving down farm profitability, and obviously the big issue around carbon and environmentalism and sustainability. And the general disruption going on in supply chains mean that we've got some major issues to overcome. Some futuristic and otherworldly concepts have been pushed around where we might go in the future over the next 30 years. What might farming in 2050 look and feel like? We all recognise the language of fourth agricultural revolution. We're at that launch point now to where things are really starting to come together around new farm production systems, new technologies like machine learning applied to Earth observation imagery and remote sensing, ubiquitous IoT sensors, Internet of Things sensors, providing data in real time across farming operations and in buildings, data-informed decision-making, robotics, etc. So I could list the technologies. There's a screed of technologies now coming into the digital agriculture supply chain world and into the precision agriculture world. And all of these technologies need or are enabled by data. From a world that was only starting to understand computers at all 30 years ago, future farmers in 2050, 30 years from now, some of whom haven't been born yet, will only know a world full of technology and fueled by data, and many of them will be performing jobs that we can't imagine yet. Of course, a lot of this is here now, actually, when we think about robotics as an example. It's not just in labs, they're out there doing their job. They are saving labor, they're automating operations, they are doing the robotics loop of sense, plan, act, with data at the heart of that loop, making complex decisions based on ML, machine learned and AI algorithms, at the edge of the network, out in the field, not sending their data back to base to make a decision. This is edge computing, where the processing power is on the device, so that this self-conscious device, self-conscious in terms of understanding its environment and understanding its placement within that environment through its sensors, can make decisions and use its actuators to then drive action. Of course, this world is full of legal and regulatory hurdles is the wrong word, but it's an area to explore. Self-driving cars, obviously, are a good example of where autonomous vehicles need to be wrapped in legal and regulatory framework. Of course, here we have robots that are going to be moving around farm operations where there will be people, and there's going to be similar requirements in these environments as well. So, so in the field, data in the field, literally in the field, shipping data over 5G connections, having that compute power at the edge, being able to use machine learned and AI techniques like computer vision and haptics to be able to allow robots, as an example, to do their thing out in the field, is going to be a critical application of the future, but it's here now. I thought I'd use an Earth observation example, just on the topic of machine learning and AI. This is something that we did a few years ago at Agrometrics for a sweet corn producer in West Africa, where we used some Earth observation imagery, and on the left there's some optical imagery, and on the right it's synthetic aperture radar imagery, and we used that imagery to create field boundaries, to track sweet corn through its growing seasons, to create our own weather models using some data assimilation, because we couldn't trust the local weather models, it wasn't accurate enough, to predict time to harvest. That was our goal with this particular analytic. And that allowed the grower to manage their supply chain commitments proactively. So this is all using, as I said, data assimilation techniques, machine learning techniques, based on the supervised and unsupervised learning of different neural networks. So I'm throwing a lot of language in here, and I welcome questions at the end about some of this, but I just want to show how a lot of the power in the techniques comes. We and others have also explored using techniques like natural language processing applied to unstructured data, like social media feeds and the like, to track and predict disease and pest spread across the country. With the satellite applications Catapult, we at Agrometrics went through an initiative called the Forest Mind Initiative, using remote Earth observation imagery to identify land use change in Brazil, to make sure that we could confirm the provenance of beef and soy products and confirm that that land wasn't subject to unlicensed deforestation. And that, again, used a combination of machine learning techniques applied to Earth observation data. It's a very, it's a growing field, Earth observation and machine learning. Many of you will be familiar with computer vision techniques that apply machine learning to imagery. to identify all sorts of things from, I don't know, injured chicks running around a pen to an individual plant that might need a little bit of extra attention as a tractor is rolling over it with its variable rate spraying. So computer vision is a key technology for the future. And that's not just optical imagery as well, it's at either side, so infrared and ultraviolet to be able to detect other things. Of course, alongside the power that can be revealed through using artificial intelligence and machine learning techniques comes a responsibility to apply these techniques ethically in terms of data ethics and AI ethics. We've all, I'm sure, heard horror stories from other industries, other environments where unintentionally biased training data has led to biased models and therefore biased analytics and results. So bias comes from a lack of diversity in terms of backgrounds of individuals and in terms of the thinking of those individuals who are involved in creating models, selecting the data to be used to train models, etc. It's mostly unintentional. I'd like to say wholly unintentional, but it definitely needs a deliberate process within organizations to screen for bias when you're looking at analytics. So data scientists, data analysts, they need education and literacy in how to make models explainable. You may come across the language of explainable AI, and that is a refutation of black box AI, which has kind of come through over the last kind of 5 years or so as being something we want to avoid, because AI isn't about just producing a result without us being able to understand how on earth we got there. So explainable AI is the key around making sure that we apply data ethics and address bias appropriately. Basically always keeping humans in the loop. And that's a theme that may come back a couple of times through this conversation. I'm going to move on to a model from a research organization called Gartner. The objective of all analytics is to produce actionable insight. Here in the UK, within the agriculture sector within the UK, we love benchmarking. And I'm going to be slightly derogatory about benchmarking now. It's important, but in many organizations I've come across since arriving at Agrometrics, those might be businesses, they might be government organizations, they might be research organizations. Benchmarking appears to be the pinnacle of analytics within this sector. I know that's a bit controversial and you can beat me back later on in the Q&A. If you've got lots of data in one place, so you are a farm management system operator with thousands of farmers' data, or you're a government organization like the Livestock Information Service, then benchmarking is easy. And on this chart, difficult is on the left, okay? Value, you can see, increases with difficulty. Unfortunately, benchmarking is not a particularly sophisticated analytic. It doesn't tell you an awful lot about what you should do, and it tells you too late anyway to do anything about it. So I kind of liken benchmarking to be on Facebook, which I quit several years ago. You get fear of missing out, and you're constantly comparing yourself with others and worrying about what you're doing wrong, probably unnecessarily. So this model from Gartner depicts the increasing value you get from data as you apply different kinds of analytical techniques to it. The model itself is now 10 years old. First came out in 2012, but it's still completely relevant. Most of the reporting we get is just descriptive. We ask enterprise resource planning systems that happen to have lots of data in them simple questions like, what was our sales this period compared to last year? Okay, so it's a performance report. We've now got to do all the work to analyze, interpret the data as humans and come to a conclusion. We've got a bit of information, we've got a bit of value, but we only know what happened in the past with only hindsight, hence that diagonal arrow. Thinking about diagnostic analytics, benchmarking starting to get there. You know, it kind of sits between descriptive and diagnostic. It's historic, but through benchmarking, we start to explore why things might have happened. Such as how our farm production system might influence yield or animal welfare or crop disease management, compared to farms that do things differently or farms that do things the same way. But how useful is it to know that compared to all other farms that operate the same way, you're in the bottom quartile? What other analytics do you get that tell you what was the cause for your relatively poor performance. What operational changes can you make in future that may make a difference for next season's benchmarking? And that's the problem with benchmarking. It's a slow feedback cycle. You only get some diagnostic if you can compare lots of other parameters and see some connection, e.g., you kind of used fewer inputs per hectare, or you simply had a freak weather event. So how do you really know what was the root cause of your relatively good or relatively poor performance compared to those you're benchmarking against? Then even if we have got our benchmarked data, do we really interpret data with an open mindset? Do we really track those through to logical conclusions? And do we really follow through on what the data are telling us? And that's a kind of a data culture, data literacy, but also it's about data, being prepared to take data-informed or even data-driven decisions. The big shift in value is when we increase the difficulty level. We go up to the higher tech end of this spectrum, starting to predict what will happen, not just diagnose what did happen. And that requires a lot more data collected very frequently, if not in real time. The use of models, like I've mentioned several times already, machine learned models, AI models, and forecasting models, providing an envelope of guesses about what might happen in the future. What's the weather likely to be throughout your whole growing season? How might that affect your yield and quality? How do you improve that prediction as the season progresses? When might your crop be ready for harvest? And predictions allow for planning. So that's the difference here as you start to go up this chain. So like in that time to harvest and supply chain example that I mentioned earlier on, it allows planning, it allows corrective action, allows, in that case, somebody to go source sweet corn for somewhere else because their sweet corn is going to be late to market. Prescriptive analytics at the top right are a bit of a nirvana. It's a natural extension of predictive analytics. If you happen to have, for instance, a controlled environment agriculture operation and your crop's predicted to be ready for harvest too soon or too late to fulfill your supply chain commitment, how can automated systems respond to the sensed inputs to tune the environment, changing the lighting and the energy input, changing fertigation rates? And that automated feedback and control loop is commonplace in other industries like building management systems and chemical process control, which is my familiarity. It's funny though, because in those industries, there was a lot of pushback from operators in such installations to start with. How can sensors and AI, it wasn't AI back then, 20 years ago, but how can sensors and causal models do a better job adjusting complex building management systems or chemical processes than people who've worked in those facilities for years? But they always did. But it was always important to keep humans in the loop, either checking before the action's taken or at least checking what the action, what the automated action did. So the analytics are prescribing decisions and actions to the business. Got another quick example in the supply chain, agri-food supply chain logistics, using AI for route planning and task allocation to optimize operations. With more value comes more foresight then to be able to do the planning. So the last thing on this slide, that optimization word in the top right is really important. If you're only tracking against one parameter, you're maximizing or minimizing it. But if you've got multiple interacting and possibly competing parameters, say yield and quality and sustainability, you've got to optimize for the balance of all of these. So if we take that logistics example I introduced, time might be of the essence, or fuel economy, greenhouse gas emissions, or food miles, or driver hours, or some balance of all of these. And depending on your scenario, you need to optimize for the right outcome or you get the wrong results. Okay. So each of these types of analytics going up the scale has increasing difficulty. It's a good indication of how advanced your company, your operation, your way of thinking about data analytics is getting. Difficult techniques require more data availability and more quality. And your data needs to be in very good order to succeed. So your company's got to be very mature in its transformation to data-driven operations. This next slide is pretty much the same as the last one, slightly reconfigured, but the additional point here is you can see this human interaction at the prescriptive level. So we're showing here that for decision support, the human is in the loop making the decision, the little green area to the right of decision support. Whereas decision automation, actually the human is allowing the decision algorithm to then drive the next best action, the actionable insight. You'd always have a human checking, but it's a question of how do you show whether the human is in the loop directly or whether it's checking behind this afterwards. On to my next favorite topic, which is data sharing. This model comes from MIT, who are quite good. And it's about breaking down data silos and sharing data and collaborating on data to get more value from data. Why do it? So successful businesses in other sectors who have transformed digitally within their sectors are successful because they don't just use their own data. They use data up and down their supply chains with government, business and research collaborators. They use third-party data that they source from elsewhere, sometimes from very surprising sources that they're just experimenting to see what can happen to supplement their analytics. And they share back data, helping to create an open innovation platform. Sometimes that sharing is open, so it's literally free data here. Industry, have some of this and see what we can all do together. Or sometimes it's traded, okay? But importantly, data on their own, e.g. one farmer's operations data is not particularly valuable. The whole data is the new oil thing is a complete misnomer. So when it's in bulk, you start to get something valuable. When it's combined with lots of other data from different sources, then they can yield all sorts of insights. It starts to become more valuable. But one farmer's data on its own, not very valuable at all in the bigger picture. Behind data sharing comes data governance. All right. Data governance within your organization. If you're a large business and you're sharing data within your organization, data governance is all around policies and data management procedures. But data governance across organizations is about data stewardship, the trusted stewardship and sharing of data on behalf of others. This model is the theory of change or logic model of the Open Data Institute. And we're a data exchange at Agrometrics. We've worked closely with the Open Data Institute over the last couple of years on concepts of data stewardship, including data trusts and data institutions. We've done a data landscape review for them of the UK agri-food sector. And data governance is a hugely important part of trusted stewardship of data on behalf of others. As data stewards, we need to think long and hard about issues such as legal and regulatory frameworks, processes, technology, culture of our organization, but also the organizations that we're stewarding data on behalf of. The people aspects within our organization, and also meeting standards like ISO standards, like ISO 27001 for information security management systems. We've learned a couple of things through these processes of being involved as a data stewardship and stewarding these kinds of discussions. Organizations generally come into this space with great intentions, but often don't have the right base point to get started on the right foot, which can lead to mistakes, unintentional, but nevertheless mistakes. So there's a lot of information sharing, there's a lot of education to be done to help organizations that purport to be data stewards to really demonstrate that they are ready for that responsibility and can be entrusted with that responsibility. I've learned a lot as well over the last couple of years in a couple of data governance discussions across the industry around this industry's approach or attitude towards statutory data sharing versus data sharing for value-added products and services. And I've pretty much seen a 50-50 split between organizations and people representing those organizations who are happy only to share data when it's required for statutory purposes versus those who are really happy to see their data leveraged for a greater good as long as their data privacy is protected. aggregate stack, for instance, and anonymized stack. Okay. Thinking about data stewardship, I was involved with conversations in the Food Industry Initiative for Antimicrobials around how do we create a space where all those competing organizations, those retailers with veterinary institutions and organizations with councils for the sectors like the British Poultry Council, how can we help those naturally competing organizations feel comfortable sharing data but privately, so that their commercially confidential data could not be seen by the others, share those data in a way that the overall analytics could be used to help demonstrate the optimization of antimicrobial use versus animal welfare. Okay, and that is a data stewardship use case that requires what the Open Data Institute would call a data institution. And how does the legal framework, the contractual framework, and the process architecture fit around the technology to be able to enable people to share data securely, knowing that the data won't be seen by the competitors, but that the results can be used in a way that facilitates this system-wide change that's required to tackle the problem of antimicrobial resistance. So getting value from data is important. Sharing data between collaborators or natural competitors who need for a particular purpose to come together around shared data. So getting value from data in those circumstances. Also getting value from data across farm management systems, so that farming, the bugbear of farming, I know, I'm not a farmer, I've not had to do it myself, but I've heard many, many times and how the bugbear of having your data in so many different systems, having to re-enter it so many different times. So how can we enable individuals to be able to pick and choose who sees what data without having to continually re-enter it? Having data in one place, or at least linked to it, looks like it's in one place. Having data available through one view, the word in the jargon in the data industry is data attracts workloads. You've got data, you're looking at it thinking, oh my goodness, there's something there that we can do something really, really great with. Okay. Again, there's a balance to be struck there between charging off trying to create great insights and analytics and ethics, consents, personally sensitive and identifiable information, etc. So how do you make sure you've got the right framework within which those value-added data services can be created? I shall quickly move on to fair data. Many of you may have heard of the concept of fair data, findable, accessible, interoperable, reusable data. Nowadays, all data is being created and shared as fair data. The F and the A are really easy. You just have a data catalog, you show the metadata, you search on tags, you find the data, it's accessible, great. The interoperable bit is where it starts to get difficult. That's where you're starting to think about how to use concepts around linking of data semantically, so representing the knowledge of my data asset and comparing it with the knowledge of another data asset to make sure that exactly like principles are matched across those data assets. It's not quite the same as setting data standards, okay? People feel setting data standards is the answer, and that can be in certain parts of the industry. But actually interoperability of data is a more generalized approach that allows you to not have to think about the standards whilst you're doing your work, whilst you're creating your data, and just being able to link your data semantically, because whoever's holding your data for you is doing that on your behalf, helps you to join your data together. So it looks like your data and somebody else's data is one combined data asset. You're searching across all of it together. At Agrometrics, and I'm sure other people are doing it as well, we are looking at how can we help people who share data through Agrimetrics' data exchange, how can we help them self-serve data linking so they don't have to do any of the work themselves. So it's all about making these processes easier and easier. All right. And an important part of interoperable data is making data machine readable. Okay, so it's not just human readable, but a machine can be absolutely sure that that concept in that data asset over there is exactly the same as that concept in that data asset over here. And that if there's a match, then they are able to manipulate the data appropriately. There's any minute doubt that these are not the same concepts, then essentially the machine can't read those two together. So we as humans may make a judgment call, but the machines don't do that. Okay, so making data, essentially creating an internet of data that makes data machine readable is the interoperable step. The National Data Strategy also mentions making data AI ready. So it's, again, machine readable. Right, cracking on through this. Standards, some standards, some of you who work with ISO bus as a standard will recognize what I'm trying to show here is there's a tractor with some machinery that is talking back to the tractor through standard connectors and interfaces. And as engineers, you know, we all recognize when standards are important. And it's about how do we get the right balance between when to have to set a standard for the industry versus when to, I kind of guess, let market forces just get to work. And how do we not have to dictate standards around formats for data? For instance, different farm management systems might use very, very different data definitions for their data capture and their data transfer. But at what point do we actually start to think a standard is required here, and we might need to get some organization to set the standards, and who actually has the right to do that? Which is the right body to get involved in such conversations? We know a few, well, ISOBUS is a clear example. We know of a few initiatives that are underway, but this is a huge debate in the industry about who has the right to set standards for the industry and what standards need to be set as a minimum versus going overboard. We're not financial markets and financial services where every transaction has a particular shape. So therefore standards are very easy to set and very important. But at the same time, by making such kind of regulatory controls happen within financial markets, they've been able to boost their industry, for better or for worse. And as a result, you know, they've achieved a lot of things over the last 30 years. Since they adopted standards like FML, financial markets markup language. Let's move on to danger. Obviously, data sharing is a minefield. We've got to think about privacy, personally identifiable information, consents for the use of those, the licenses to use different data. We've all heard horror stories of organizations who perhaps have assumed they've had more authority or more control over the data that they hold than they really ought to have. And the unfortunate situation is that farmers as individuals and as farming operations are terms takers when it comes to terms and conditions for contracts, when they're using machinery or equipment, when they're signing up to farm management systems, etc. There's not an awful lot that an individual farmer can do to change terms so that they can feel slightly more protected than the standard. So the standard needs to be fairly well defined in a way that the marketplace feels comfortable with. So yes, a lot of danger when it comes to data sharing. Hence the need for data institutions and that whole data stewardship mindset and language. More danger, cybersecurity and information security, because obviously all of this automation creates massive risk. I was on a recent podcast talking about how agriculture really needs to be treated as essential, if not critical, national infrastructure. There are some key components within our sector that if they were knocked out by a hostile actor or by ransomware, our industry could be in a bit of trouble for some days, if not weeks or months, depending how long it took to recover from. And you know, a lot of people in ag think, well, wait, we don't need to worry about this stuff in agriculture. We don't have that much data that's really that important that anyone's going to really take seriously and try and do something with. But in fact, a well-known hostile actor that's currently being hostile to people over in the east of Europe is very likely to be scanning the ports of all of our networks at the moment in order to understand, is there a vulnerability there that I can take advantage of, through which I can either plant some ransomware or more likely take over operations to try and change data. Changing data is the way that a hostile nation actor attacks infrastructure at a national level. Okay. Quick thoughts on data management and data management maturity. This model, this framework by the CMMI, it used to mean something, but it's now just CMMI. It used to be the Carnegie Mellon something Institute, Management Institute. So this model is a really good reference model for organizations to go to have a think about how mature they are on each of these different parameters. There's a lot of definition behind each of these points. You do a little questionnaire, you come up with a spider diagram at the bottom that compares where you want to be with where you are, and you can then adopt a kind of a gap analysis and an approach to improving your stance, your position on data management maturity. Most importantly, data needs to be strategic. It needs to be a board level discussion in most organizations, but it isn't at the moment. And the culture of organizations needs to become more data informed and data driven. And more senior people need to be more data literate, but many of them aren't. Large organizations, I did a piece of work with a multi-billion-dollar agri-food company. I'm not going to give anything more away, but I was really surprised that that company did not have a data strategy, a chief data officer. They had one data analyst across their whole organizations, multi-billion-dollar, multi-country, and they didn't know where all their data assets were. They didn't have a data catalog. Okay, so these things are kind of entry level if you're going to take data seriously going forwards. Getting that strategic buy-in, sorting out governance, operations and processes, understanding your data life cycles, capturing, storing, processing, mixing, matching, emerging data internally and externally, analyzing, retiring data, getting rid of data at the end. And what are all your roles across your organization who have something to do with data? So the chief data officer themselves, or somebody who has that responsibility of chief data officer, if you can't, individual, data stewards, data analysts, data scientists. So culture is important. Literacy is important. Data literacy is important, and driving or informing decisions through data. Genuinely driving or informing decisions through data, not just saying you're going to. And actually having that, we mentioned data ethics earlier on, enshrining what you will and what you won't do through a data ethics or data advisory panel. Okay, so to wrap up, I think across the UK agri-food sector, I'm going to be a bit controversial here. I think data is often not viewed strategically by many organizations. Data literacy is pretty low. We don't make enough value or don't get enough value from predictive and prescriptive analytics. Still too many data silos. People don't want enough to collaborate around data, possibly because they don't understand enough about what the benefits could be. And we really do have poor information and cybersecurity in this sector. You know, for us at Agrometrics, our top line at the introduction was by 2050, 10 billion people fed through data. It's about becoming the data exchange powering the world's agri-food sector, and our values back that up. And all of us, I think, know that this sector, the agriculture, agri-food, environmental sectors, needs system-level change. Data analytics are a critical part of making that happen. And we all need to change up the way we think about collaborating around data, making the best use of data if we're going to make better decisions and create valuable, actionable insights, if we're going to have a chance of feeding 10 billion people by 2050. So I shall pause there and stop presenting. I'm now reading the questions. So Mark has asked, how do you envisage, i.e. what mechanisms for data input and transfer from individual consumers to shops, from shops to wholesalers, and wholesalers to the farm. Okay, thanks, Mark. So part of the change up over the last 30 years has of course been the development of the consumer app and the power that is now sitting in all of our hands to influence all sorts of things at the touch of a button, with likes and dislikes, with buy decisions or sell decisions. And I think an awful lot of that touch point in terms of provenance now, we've already seen as we've done work, and I'm sure many of you have as well, as we've done work up and down supply chains, we've seen a deliberate connect right up to the consumer. Okay, so a number of, for instance, the grant-funded projects we've been involved with have involved consumers as well as retailers and back up the supply chain to the farming operation themselves, sometimes in other countries. So that joined upness from end to end, up and down the supply chain, is already there. Okay, is there anything specifically you're thinking about there in terms of what mechanisms for data input and transfer?
I was thinking that you're absolutely right. The first thing you did is you reached for your phone. And what I think of is sort of 30 years ago, the mobile phone wasn't a thing. That's 40 years ago. And you know, I'm sure there's going to be something that's going to come after the phone. But all these technologies require the user to want to give an input. And on something as bland as, I don't know, something you can pick up in your supermarket, there's very little motivation for certain end users to give a broad feedback. And that's really sort of how, you know, I was wondering how in the long term we're going to get feedback on a broad range of data on products back to the farm.
Okay,
and for me, back to the farm machinery, actually.
Yeah,
But it's got to start with that initial getting someone to enter data.
Yeah. So supermarkets already put a lot of effort into this in terms of joining up their point of sales and their shelf stocking systems right the way back up the logistics supply chain, right the way back into farming operations. I think most of us are already aware that there's an awful lot of joined upness and just in time data operations and therefore operations going on there. I'm going to be a bit controversial. This is a middle class problem, okay? Because unfortunately, it's the middle classes who have the time, the energy, and the consumer drive to actually pick up the mobile phone and give feedback like that says, I didn't realize this came from Brazil in deforested lands, not under license, so I'm not going to buy this anymore, and I'm going to actually write it. So unfortunately, there are a lot of people who won't be enabled to influence the production patterns in a way that they need it to be influenced. Okay, and we see that a lot in terms of poverty of this, poverty of that, whether it's fuel poverty and other poverties. There are a lot of people who don't have the opportunity for their voice to be heard. Okay, so but those who do have the opportunity for their voice to be heard, so people who can afford an iPhone on a contract, I make choices all the time on this device, and those are already being fed up the supply chain by savvy retailers who understand that that's where the high margins are. I've been overly controversial there.
No, good observation. Thank you.
Thank you, sir. Declan, thank you very much for your comment. I don't think there's a question there, but if there is, please come on in a second. Jane, lovely to meet you again, Jane. You've asked about fishing for patterns. And You're right. I mentioned earlier on about explainable AI, and that's so important, isn't it? That we need to make sure that even if we are fishing for patterns, we've then got to understand what those patterns were that we've discovered. And there are a lot of people who simply fish for patterns and then hypothesize after the case. Now, I'm not a researcher, so I might be one of those bad people who does it the wrong way round. But at least if a team that I'm working with does discover something interesting suddenly out of data, we spend a lot of time trying to work out why and how.
Okay, I think that's most of them. I've got one question, Benjamin. I was previously in my previous business, I was on the technical committee, and we were talking about AI and the regulation of AI. And most regulation of AI is aimed at cars, basically vehicles, because they can run over people. But obviously, we got tractors and other robots, and I think the regulation, there will be regulation on these vehicles at some point. And I wondered how future regulations would affect the collection of data accessibility. And also you got the GDPR type influences. My organization, we were global, and so there was a lot of restrictions on sharing data within our own group. And I just wondered, with extra regulation on AI, what do you think would be the result of that, and would it be more prudent for our industry to push regulations ourselves quicker rather than being enforced on us? If that makes sense.
Can I do the second question first? I think it's
Yeah.
always prudent to beat the regulator if you can. Mm-hmm. And we can see what, as we mentioned when I was talking, but you've just asked again as well, we can see that there are going to be a lot of crossovers and similarities between the autonomous self-driving vehicle space and the robotic space on farm with people and animals in the same vicinity as robots. So we can probably already anticipate the kind of regulation that's going to come down the line, and we should. Yes, I would suggest we should volunteer ourselves into some of that to show that we're moving in the right direction. It would be terrible if robots that are deployed on farm now cause accidents and harm in an industry that already doesn't have the best reputation for safety compared to other industries. Okay, that would be terrible. So how would equipment manufacturers around robotics feel comfortable managing that balance, okay, of being able to deploy, but also doing it in a way that they feel less terrible about? So I think in terms of, it's interesting, I've come across this with other organizations as well, where they've had difficulty sharing data between their own groups within global organizations. It's bonkers, isn't it? Yeah. That's the case. And you can kind of see in the medium to long term a normalization of rules and regulations around data privacy and GDPR, well, GDPR-like data privacy concerns. So there will always be differences. Countries will make their own rules, but essentially there will be a broad normalization around what's common sense, and amongst the biggest markets that wants to share data between them. We've seen that ourselves. We have to now think very carefully about data sovereignty. As we're starting to look around the world at organizations that we're working with and for. So where do we host data? Where are we allowed to process their data? Whether it's Australia, whether it's Brazil, etc. So industry will work really hard to push back on governments to make sure that we try and normalize this approach, because otherwise we're just carrying this huge cost burden to trying to make data, this collaboration around data work, because we're global businesses. We can't just think in isolation within countries. I don't know if I've answered part of your
Yeah,
question.
you have. Thank you. Yeah, you have. Thank you very much. Yeah, I think Hugh's got a question there on the chat.
Data use started from manual records, perhaps through to fully closed loop automated systems. How long is that timeline in ag, do you think? And we're on it right now. There are some fully closed loop automated systems at the moment, but I think they're quite small scale. I've seen, thanks to visiting Jane up at Cranfield or visiting Simon Pearson over at Liat and others, I've seen lots of great examples of research, but applied research working in the field right now. Okay, so I think that fully closed loop automated systems work and are ready to scale in the UK. In other countries, they're already there. It won't surprise you to hear me now say, just pop over to the Netherlands and see what they're doing over there at the moment. That picture I had at the top of my presentation on my title slide was a CEA environment in Netherlands that is always on, chucking out, what is it that Netherlands is now? #2 or #1 tomato producer in the world. Apparently the tomatoes don't taste so good, but it's still the #1 or #2 tomato producing nation in the world for quite a small country. So, so I think, it's here in the UK, perhaps our way of doing business here. It's not just about the UK agriculture sector. It's about how we do business in the UK. We're a lot more laissez-faire than other countries. And as a result, I just think we've got a bit more sorting out to do to get some basics right.
And thanks for
Mark,
that.
is the cloud a secure data storage? So in my humble opinion, absolutely. But I'm judging that on the basis of working with Azure, and I've worked with AWS and Google in the past in different environments, on the basis that they have invested billions of dollars more than I can ever invest on security, cybersecurity, information security, on geo-redundancy, on business continuity and disaster recovery, etc. So as far as, so I mentioned ISO 27001 as a standard that I think all organizations that process and analyze data, and certainly that aggregate data on behalf of others or steward data on behalf of others, they must have it. And that's one of the easiest ticks in the box for us, was to be able to say, we're hosted in Azure, we're geo-redundant, and we have these services, we have business continuity impact assessment, we do penetration tests and vulnerability assessments regularly. And as a result, it was very easy for us to get that accreditation. If we had built our own infrastructure, it would have been, and I've done that in the past 25 years ago, it's significantly harder to get those kinds of accreditations.
Benjamin, it's interesting to hear that you mentioned about the data stream from the supermarkets. I never appreciate that, but that could be a massive stream back to their team members, if you call it the people that supply them. There's a massive satellite information database that people aren't aware that all their farms are being monitored anyway. And then there's the farmer themselves. I presume they would be the weakest supply of data, or is there another form of data that is involved as well?
Thanks, Declan. So the farmer, did you say the weakest supplier of data?
Well, like
is that because it's small data?
Stream. The stream supermarket is great. The satellite's huge. The farmer then needs to send back some local data.
Yeah.
Is there anybody else in this model that I've forgotten?
So farmers through their farm management information systems. You've got your organisations like Livestock Information, which I know a little bit about. I can't talk about the inner workings, but being on their data advisory panel, I can say that organisations like that get requests for data. The data advisory panel often turns those requests down, I must quickly say, but they get requests for data from all sorts of different organisations and operators in the sector. So, for instance, a large milk cooperative might have said, well, we know who our farmers are. you've got some data associated with our farmers and their operations, can we have access to those? So that might be a way to get certain farmers' data via another route, not easily granted, I must quickly add.
Yes.
Okay.
Oh, that's fantastic, because I didn't even think about the milk producers as well. So when you start about that, you go about grain producers, all the suppliers of the raw material from the farmers. So there's a huge amount of people, data other people have. But so then you said the farm management systems is another hive of data then.
Yes, and you know, the farmer, because the farmers themselves, okay, again, I'm not a farmer, I don't know the answer to this, but I suspect from the farm management data I've seen, a lot of it is collected sporadically rather than through live real-time sensors and data feeds.
Yeah.
Even things like I'll be quick because there's only a minute or two left. Even things like feed data can be quite approximate and sporadic, and therefore you can't really trust it too much. So what actually is what is actually trustworthy on farm data?
Yeah, I agree now. It's coming to me what you're saying. So what can happen is people in big teams like yourself will proxy the farmers' information. So what will happen is there's so many other external databases now that I didn't appreciate until this talk that could proxy the farmer's information, and then we'll tell the farmer what you're supposed to do. So the farmer, we need as our institute to protect the farmer and help the farmer appreciate what's going on out in the big world. So I think I learned that from this. Thank you.
That's very kind. Thank you, Declan.
Okay, so thank you very much, Benjamin. That's really interesting, and thank you for all. You know, I've learned a huge amount in this past hour. And it's a massive subject, and I think we could talk for hours on this. But we do appreciate your input, and thank you very much.
I appreciate it a lot. Thank you all very much for your time. Fire me questions. I'm delighted to talk with you offline about anything you've got on your mind. Cheers.
Thank you.
Thank you very much.
So thank you, everybody. Obviously, we're at the end of this lecture now. Can I just mention the next one, which is on the 18th of October. We're going to be joined by Mark Kibblewhite, who's a fellow of the Institute and a soil scientist, an environmental chemist, and the current chair of the Dorset Wildlife Trust. And Mark's going to talk about the subject of wilding and the potential opportunities for engineers. And also, I'd just like to mention before you go, the annual Landwards Conference is held at the East of England Showground in Peterborough on the 1st of November. Our subject this year is engineering, sustainability and agriculture, particular focus on soils. We've got some great guest speakers lined up, more to come, and full details are on our website. So thank you very much for joining.